Hello and welcome to SudoKanard. We are here to solve this region sum line Sudoku by Indian author Akash Doulani. He published this on his blog a few hours ago at the time I'm doing this video. And region sum lines is a variant, an arithmetical variance of Sudoku with which I sometimes struggle a little, and I thought it would be interesting to try this puzzle by Akash. So the special rule here is that on each of these lines, well, these lines, such a line encounters several regions, and in each region, the regional sum is the same. For example, the sum of those two digits is equal to this digit and to this digit. The sum of those two digits is the same as those two digits, and so on. So we have a very fancy looking board at this point. And I'm seeing with fours that we have a 4 here, which is very interesting because it means that 4 is the sum of those two digits, so they have to be 1 and 3, and this is also a 4. So that's a kind of easy start. Now we have the fact that we get a lot of clones here. This digit is the same as this. So it's neither of those digits. It can still be 1, 3, 5, and 6, but 1 is not possible because 1 can't possibly be the sum of those two digits. But I think that the other values are all possible. 3 would work with 1 and 2 there. 5 would work with 2 and 3 there. And 6 would work with 1 here, and 5 there. So none of them is to be ruled out at this point. So this can't be any of those numbers. It can't be 2 either. I don't think it can be a 3 because if that's a 3, then we have, well, actually this digit here can't be 1 or 2, so 1 plus 2 is not feasible. So 1, 2, 3, 4, 5 seems to be an option. The 6 is not, 7 is an option, and that's all. But we must remember that the digits here are small. So I think that 3 and 5, yes, and we must think that the sum of those 4 digits is the sum of this plus that. And without using the 4, the minimum value with 1, 2, 3, and 5 is 11. So this plus that must be at least 11, and 3 is not possible. So that's correct. Could we really have 11 with 1, 2, 3, and 5? Well, this is neither 1 nor 2. With 5 here, that would be 3 and 2. And here 6 would work with 1 and 5, so that seems to be possible, except that this could never be 5. So that would break. So I think that 5 here is really not an option. This is 7. So this can't be 1, 2, or 4. So this is from 3, 5, 6. Let's just see that 7 goes here by the rules of Sudoku. 3 would come with the 4, that's not an option. So this is 5 or 6, and this is 1 or 2 correspondingly. The sum of those two must be 7. Now, 5 here would require them to be 2 and 3. Oh, and that's interesting. 6 here would require them to be 1 and 5, in which case we would have 2 and 6, which sum to 8, not to 7. So actually this is not 6, this is 5, with 2 and 3 here, so that this is 1 and 6. and we finally get the 5 here. And I could have seen that this digit, whether it had been 5 or 6, had to be somewhere here by the rules of Sudoku. All right, so let's move on to some other place. This column needs a 4, so that's a 4. And here we are left with 2, 3, and 6. And here we are left with 5 and 8. That's not a 6 because of that. And 2 is not an option because 2 is not the sum of those two digits. So that this is a 1, 2 pair. And this is a 3. Here we need 1 and 9. Now, what can we do? I don't think 1 here is possible. If this were a 1, this would be a 9, and this would be at most 8, so the corresponding sum would be at most 9. But the other way of having those two digits sum to less than 9 is 2 plus 5, which is 7, and this can't be a 6, so that doesn't work. This is actually 9 and 1, and 2 and 1, and 3 and 1, and 6 and 2 here. So now, what are the options? 6 plus 5 would be 11, but this would have to be a 2, which is not allowed, so this is finally 8. The sum is 14, so this is 5, and this works. All right, here we need 2, 8, and 6. Actually, 6 goes there with the given 6's. This 2 goes there. This is 8, and we can have this 3 and this 2. This column, the column, oh, I'm seeing that this 4 doesn't go here, it goes there. There we need the 9 and the 3. Down there we need a 5, so it's here because of this 5, and that's a 6. This row still needs 3, 8, and 9, so this is from 8, 9, this is from 3, 8, this is from 3, 9, and actually it's not a 3, so this is 9, this is 8, this is 3. Here we need 5 and 9, here we need 2, 7, and 8, so this is a 2, this is a 7, 8 pair. Here we need 1, 3, and 6, but this is never a 1. This is never a 3 because this would have to be a 1 or 2. So this is actually a 6, and it is cloned into this cell. We have a 1 and a 3 there, so that the sum making this 6 is 2 plus 4, like this. We need 7, 9, and 6. 6 can only be here, and this is a 7, 9 pair. Here I need a 1 and a 3. Oh, that's the 1, that's the 3. Here we need 8 and 9. So the sum is either 9 or 10. And those two digits will disambiguate the lot. 2 here goes there. 2 plus 8 is not available, so the sum is not 10. The sum has to be 9. So this is 7. This is 8. This is 9. And we can see that all those are compatible. 7 here, 8 there. And the rest is standard Sudoku. This 9 makes this a 3. This a 9. That's a 1 because that's the remaining digit on the column. This is 5. It disambiguates the digits at the bottom, but actually this 9 would have disambiguated anyway. This is 4 and 8, so 4 here, 8 there. This is 1 and 2, so 1 here, 2 there. That's the 3, that's the 1. That's the 3, that's the 9. And this is it. So really not that hard for a puzzle of region sum lines. And that was really solvable by, I would not say by very easy logic, not even straightforward logic, but safe contained logic. and absolutely no struggle involved here. So good job. Then Akash is not a beginner setter, far from it. Thanks for watching this video, and see you soon on SudoKanard.